Oh, you know what's really weird? You can go onto Amazon and you could buy a thing called, they have like a weird name for it, but it's like a form-fitting weight for the left-hand side of the steering wheel for a Tesla. So you don't have to put your hand on the wheel like when it's on autopilot. Like I get that people would want to do that. Like, you know, maybe they like put like ankle weights or something like that on there to like try to fake it, but to be able to sell something like that seems illegal, doesn't it? And they all like it's so overt, like they try to like frame it as like it's actually like a phone holder, you know, but they're like talking about how, you know, this thing weighs 2 pounds. And it's like, have you ever like wondered how much your phone holder weighed when you purchased it? I don't know. I'm just gonna tie an orange to Mr. Gonzalez's legs and have him hanging from the steering wheel. That's the better way of accomplishing that, I think. All right, so I'm not going to spend a lot of time on the exam. I just want to go through kind of the couple things that were heavily missed. I think the class average was maybe an 80, mid to low 80s, 84 maybe, something like that. In general, people did pretty well. There was just a couple of pretty low scores that offset it. I especially liked your response to the your conversion question, where you kept inserting comments. I think that was you, right? So I think I went back and looked. Yeah, so let's look at that first. So this question, it seemed like it ticked some people off. I gave you this question for it to be easy, with that understanding that we're converting from octal to binary. So octal, we can cover the entire 3-bit space, all the octets with 3 bits. So if we are doing this conversion, and then I want to get over to our coding for our Rot13 stuff. I'll just put this right after the. Is Noah not here? He's here.
I'm here.
Oh, did our Samba guy get out of the hospital yet after I messed him up? Is he still in?
No, they're not expecting a full recovery.
Yeah, that makes sense. I don't even know a couple of those moves I did, but they were good. All right, so we want to convert this number, octal, to binary, and this is one of our shortcut guys. So, you know, the idea is a 1 in binary is a 001 using 3 bits. A 3 is a 011. A 6 is a what's a 6? That's a 4, a 2, and a 0. A 2 is a 010. A 7 is a 111. A 4 is a 100. A 1 is a 001. A 3 is a 011. Another 3 is a 011. And then a 5 is a 101. So you just write those all out. So that's 001, 011, 110, 110, 111, 100, 001, 011, 011, 101. Done. So assuming I did all these things right, I wasn't paying all much attention when I was doing it, but I think that's so that's a 0, that's a 3, that's a 6, 4, 2, that's a 2, that's a 7, that's a 4, that's a 1, that's a 3, that's a 3, that's a 5. Yeah, that looks right. All right, so that question was meant to be easy as long as you have remembered how some of how the shortcuts work, right? Where I had a couple of comments where like I spent 2/3 of the time on the test on this one question. Yeah, so hopefully, and really it wasn't necessarily missed heavily, but some people did this the long way, which was not necessarily the intended way of doing it, but whatever. Okay, so let's go back here. Another interesting one was this one, and I kind of was fairly lenient on answers, but it kind of forced you to look at how the pointer syntax and things like that worked. So we've defined two variables up here. Both of these guys are of type integer pointer. So both PC and C are both capable of holding memory addresses of integers. This line right here is the weird one. When we set C equal to 5, what we're saying is that C holds the memory address 5. Now, realistically speaking, this might throw an error depending on the C compiler you're using. You might need to say like 0x5 or something like that. You're basically hard coding a memory address. I mean, 5 is a legal hexadecimal number, but in order for C to treat it that way, depending on your compiler, you might have to say 0x5 or something. But that might have given away the trick a little bit. So we are setting C, which is a bucket capable of holding a memory address, equal to the memory address 5. Then we're setting PC, which again is a variable capable of holding a memory address, and we're setting that equal to the address of C. Okay, so the address of C is what? Some other memory address. It's where C lives. Technically, this guy is actually going to be, the thing that will come out of this will be a void pointer that we're then putting into an int pointer. So when we say print out the decimal value that lives there, so %d is going to be a decimal value, correct? We're saying print out the decimal value that lives there. It's going to say, I'm going to go to this memory address, the memory address currently stored inside of PC. I'm going to get its value, whatever that value is. We never put a decimal value there, right? But presumably it's got a collection of zeros and ones in that place, whether it was zeros and ones we put there, or zeros and ones somebody else put there. Memory holds a collection of zeros and ones. So we're going to go to that place in memory and we're going to say, whatever you find there, give me the decimal value of that. All right, so this is going to print out a decimal value that is, presuming it doesn't give you a compile error. So it'll give you the decimal value of whatever bits are found at memory address PC. All right, that makes some sense. So this was a syntax, a pointer and address syntaxy thing, hence the reason why it's kind of so short. And it wasn't really heavily missed, but I got a lot of different answers that got reasonable credit, I think, for it. All right, that one was fine. This one was fine. Like most people got number 5 right, but then there was like 2 or 3 folks who just like basically left it blank. So sudo stands for super user do. So sometimes we need to do things with elevated privileges. So we need to do something as the super user. And an example of that was insmod and remove mod. When we are loading something into kernel space from user space, in order to have permission to write something into kernel space, we have to do that as the super user. That one was fine. That one was fine. That one was fine. And this is kind of that same question. I think this one was the same people who missed the sudo basically missed this one. The memory is mapped differently between kernel space and user space. So in order to move stuff from user space into kernel space or from kernel space to user space, we have to use these predefined functions from uaccess that will say, here is the value I found here in kernel space, and I'm going to give it to you to the place that you want in user space, and I'll do the weird mapping that has to occur. Okay, so questions about if you have questions specifically about grading on your exam, you know, talk to me offline on Slack or something. But in general, the exams were good. In fact, since, like I mentioned, the first 8 weeks, we walked through a lot of code, but we haven't written that much code ourselves. I did like that. I mean, I'm pretty sure just about everybody got the Hello World program working, which seems somewhat trivial, right? You know, most of us are juniors or seniors at this point, but you're still operating in a language that you haven't written that much stuff in. So I think that went pretty well. I did give a little bit of the benefit of the doubt since modern compilers will make it work, but technically a C program main should take in a argument count as well as the collection of strings. So int argc, char pointer argv. A lot of people didn't put that, but it does still technically compile today. But do remember for a lot of our C applications do take command line arguments. So having that ability for command line arguments is probably a relatively important thing. But it does compile. I went and checked it. All right, so any high level questions about the exam? Okay, so let's jump over and let's keep talking about our Rot13 thing, which we're ultimately going to set up for some inter-process communication, sending secret messages between multiple processes, but we need to have our core algorithm thing working, which is going to give us some practice, practical practice writing stuff in C. So let's see, go back to this here. All right, so we talked a little bit about this last time, that we have this thing called Rot13, stands for Rot13. The more common name for it might be the Caesar cipher. Julius Caesar used this for sending encoded messages to and from his people. So this assumes an alphabet of 26 characters where we rotate 13, and the convenience of this is that encoding and decoding is the same algorithm. We always can go forward 13 and we can always go backward 13. It doesn't matter because it wraps around. All right. So we want to look at the way for mapping a single character into that today. And then for homework, we will finish this thing. So have we started this already in here? I don't remember. Did I create a Rot13 thingy? Okay, so I'm going to go ahead and I'm going to create a new folder. We're going to call this guy Rot13 IPC. Did that put that under this guy? Yeah. Oh no, I did create it. Killing me, Brocker. All right. So we prototyped our function in code Rot13. We also prototyped this function called index of, because we're starting to mess around with strings. So we wrote index of last time. Index of takes in a character we're looking for, takes in the string we are looking in, and also takes in the length of that string. All right, because using there are string libraries that exist in C, but we're putting ourselves in the shoes of a traditional C programmer where a string is a char pointer. Okay, now could we write a function that gets the length of a string? So when I have something like alphabet here, and I set it equal to this string literal, if I wrote a function here, let's do something like int string length, and this takes in a char pointer s. I'm pretty certain this will end up working, but I guess we'll find out. And this guy's job is to take in this string and return the length of that string. All right. How would we go about figuring out the length of this string? Based on
You just copy the function you have in the index of function where you walk the length of the string and just count.
Okay, well, how do I know when I'm at the end of the string? Inside of string length. So this is your whole world right now, string length. I have a character pointer that's passed in that's presumably a string. How do I know I'm at the end of a string?
Isn't it when you reach it, or you reach the /n for new line, string termination character?
Do all strings have to have a new line?
Isn't it /0?
Yep, /0. So we're going to start count off at 0. And what we're going to do is we want to just keep walking from our base address S until we bump into a /0, right? All right, so S is a pointer. So I'm going to go ahead and I'm going to say, while *S, that is the value found at S. What kind of value will I find at S? S is a memory address. What kind of value will I find at that memory address?
Wouldn't it be the first element in the string array?
That doesn't tell me the kind of value I'll be finding. What kind of value will I find there? A char. All right, so I'm going to find a char. In this case, the first time through, it'll happen to be the char found at the very beginning of that guy, right? So I want to know, while that char right there is not equal to a /0, I want to say count plus plus, and then I want to say, I want to do pointer math. So I'll say S is equal to S plus 1. Where 1 is 1 byte. So I could also say S is equal to S plus size of char. That would also let me do it. Although I think pointer math will actually always treat it as the right thing relative to the type of this. So if I said size of int here and I was dealing with an int pointer, it actually would take the incorrect size step. It would always be S plus 1, regardless of whether I was dealing with chars or whether I was dealing with ints. I'm about 99% certain that that's true, because the compiler will look at this guy and say, what kind of pointer is that? It's a char pointer, so plus 1 means take 1 byte step. If it's an int pointer, plus 1 would mean take a 4 byte step. All right. So I will keep walking to the next character, the next character, the next character over and over again, doing pointer math here. So what am I doing here? I am updating S to be the old memory address plus 1, the next character over. And I'll keep doing this over and over and over again until I finally bump into a /0. And then I'll go ahead and return count. Okay, so I'm going to go ahead and comment out these things here. And we'll go ahead and say int length is equal to string length of hello, something like that. And then we'll do a printf. %d length. And the hope is this guy gives us a 5. So there's our 5. If we bang on the keyboard a little bit more, more stuff in there. Gives us a bigger value. Now, keep in mind though, we can hijack this a little bit, right? If we somewhere in the middle of our string put a \0, presumably maybe you've allocated, and we've seen this several times in our code, right? Where it's created a buffer and said, we have a buffer of, what is it usually, like 100, something like that, or 1,000, whatever it is. You know, I'm going to create some memory that's can hold 1,000 characters, let's say. Well, chances are we're not going to have strings that are 1,000 characters long. You know, we might store in there a string like hello, which has 5 characters. Maybe we have a string called elephant, which has 8 characters in it. Well, whenever we store a new thing in there, we're not overwriting all the other memory. What we're doing is we're filling it from the beginning up to a point and then terminating it with a \0. So after, like if we went from elephant to hello, you would replace the first 5 characters with HELLO, and then you would replace, what is it, ELEPH, the A in elephant would become the \0, but then you would still have the NT in there for the rest of the elephant. We just wouldn't get to it if we were dealing with this guy as a string because the string has already been terminated. So we'll see this guy here. So now its length is 8 because I artificially terminated it early. So this guy actually has 2 termination characters in it. It has the one that I hard coded in here, and then it has the one that gets automatically put on when I'm dealing with string literals. Now I do want to, here I'm going to say something like char pointer C is equal to this guy. I'll take the \0 off here. I'm also going to do a %d \n size of C. What do we predict that's going to give us? So again, this is kind of like the code from the exam. So C is this big long string. We've already seen what this first thing does for the length. What I'm interested in is the second value here, which is going to right now give us the size of C. What is C? What kind of value does C hold? Okay, which is a what? Memory address. So this is going to give me the size of that memory address. And we're presuming this is, maybe it's a 32-bit system. So maybe this is going to give me 4 bytes. Maybe it uses 48 bits for our memory address. We'll see. Oh, that's actually a good point. It's a good point. Oh, no. It's correct. Size of returns an int. Yeah. This guy here is a memory address. This is saying, tell me what the size of that memory address is. This is almost like a scale. You know, we're weighing it, if you will. Gives you a long unsigned is what size of actually returns. It's not a problem. Now what's an int? Hold on, I want to test something here. Oh, we're actually fine. I think it may be just, we'll just add to it. Just want to make sure we're getting the right values. Yeah. So this gave me an 8 for size of, so 8 bytes is actually a double word. So it's a 64-bit memory address, right? Okay. No, wait, is that right? Yeah. 8 times 8, 64. All right, so that's a 64-bit memory address, 64-bit version of Linux. makes some sense, right? So this 8 right here is the size of C, which is a memory address. Now, what if I say size of star C? What is this? What is star C? What kind of value is that? A char. How big do we expect a char to end up being? Probably 1. So this is 1 byte big for a char, because typically in C it treats chars as using the ASCII character set. So it's a byte for a char. Okay. So if we use size of, we can't quite get the length of a string, because the length of a string, we can get, this is the base address of the string. So we can say how big is the address. We can say how big is a single character in the string, but we can't seemingly use size of. I actually think there are some libraries that would probably in string.h that would, there's probably a strlen. I think it's strlen. Of C, and I think it's in string.h. And here, just to make sure that these guys match each other. Right? What does, oh, size T, interesting. Long unsigned int. Now it's an int. So we wrote our own length method, but there is a string.h library that has some stuff in it for working with strings, and one of them is string length. All right, but we wrote our own, we saw how it works. It's looking for that \0, so it proved it to us, right? Okay, so we can get the length of a string now, so we don't actually have to pass in the length of a string. So down here, when we did index of, we were passing in the length of our string here, but we actually can just say int, what is it called? S length is what I wrote it as. And this guy will be string length of S. Or we could have said strlen if we wanted to use the built-in library, but we'll just use ours. All right, so there's a workaround for not actually having to pass the size of the length of a string. We can use old string literals that are terminated with \0s. We can get the length of those guys. All right, so we don't need alpha length here, which means we don't need this guy anymore. So we've updated a little bit. All right. Get rid of this for a second. All right, so now we know how to get the length of a string. So the next thing we want to do is, how do I get, last time we wrote this index of function that works just like string, the Java's index of method, which goes through and says, here is the index of this character. So if I say index of the character R in alphabet, and then I print out, print it out beforehand. Oh, well, this is fine. I'll printf index before I start doing mathy stuff with it. We'll come up here and we'll still call, so we'll get rid of those couple of things from our example we just wrote. So we'll encode Rot13, pass in, right now we're doing a, I'll do an R for our example. So I can still put in C here. C is my char that's being passed in. So I'm going to call index of with this whatever character stored inside C, passing it the string I'm looking for, and it's going to return for me some index. Oh, I have to change my prototype for this because index of no longer requires the string length. All right, so R is the 17th. There's that bucket 17 in that guy. Okay. So the question we had asked last time, and we can go ahead and do it inside of encode here, is how do we find out where our next character is inside of here? So we need to know whether or not we've wrapped around, right? So we're going to get our index. Index is going to be the position of R here. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We want to get an E out of this guy, right? All right, so how do we do this math where we can add something to our index, but ultimately get it to wrap around? Because right now, if I say, so index we just saw is what, 17? Is that what I said it was? Yeah, 17. So right now, by our example, we have 17 plus 13, which equals 30. That's a problematic position in a string that only has legal buckets 0 to 25. Okay, so how do we make this 30 actually look like a, what do I have, 9, 10, 11, 12, 13. So actually look like a 0, 1, 2, 3, 0, 1, 2, 3, 4. Actually look like a 4. I need this 30 to actually become a 4. So what do I need to do to this math problem right here to ultimately get this 30 to become a 4?
You can, if you just add the 13 to the current index, if it's less than 26, you're good to go.
Subtract 26 from it.
Let me subtract 26 from the 30.
Yeah, so do a check to see if it's over 26. And then if it's over 26, you'll get the correct index to restart the check.
Okay, so Brocker was saying the same thing. So he asked if index is greater than 25.
Si, senor.
If it's greater than 25, then we're going to say index minus equals 26. Okay. And then we can do a, we're already printing out index. We'll print it out again. This should be the mapped version of it. So there's our 17, there's our 4. If we change that from an R to like a B, B was at bucket 1, and it maps to a 14. Okay, fair enough. What if I said we had to do this without an if statement? So we want to accomplish the same thing here, but we're not allowed to use an if statement. Okay, how can we use modulus to solve this?
So if it's, the index is going to be less than 26, so just return the original index. So maybe if it's more, it'll basically do the same thing as subtraction.
Okay, but that
It'll return the same value.
doesn't that require an if? Well, how are we doing your mod?
You you say index equals index mod 26.
Okay, so, well, can we do that?
Yeah.
So if it was a 30, 30 mod 26, how many times does 26 go into 30? One time with a remainder of 4. What if we had our example of our B, which takes us to a 14? 26 goes into 14 how many times? 0 with a remainder of 14. It's already the correct value. All right, so we can add on to our index our 13, then mod it by the length of our alphabet, right? And that's going to give us our wrapped value. We'll see that this guy gives us the same thing. Not that asking the if statement is incorrect. And let's change it to a, so that was right. And then let's change this back to an R and we should see our 4. So there's our 4, gives us our same output, but now we're doing it with modulo, which will be more efficient than asking a question. Okay, but the other way was fine as well. All right, so now we are mapping a single character to its Rot13 equivalent, right? All right, so if I do encode Rot13 right now, I now have this index, which is my encoded version, right? So we've proven this. That's the position of it originally. This is its encoded position. So how do I return the character that lives at that position? Because ultimately encode Rot13 is going to take in a char and encode it into its Rot13 mapping. So now that I know the index of the encoded value, so for instance, R4 is that E. So if you had passed in an R, you ultimately want to return an E. You don't want to return a 4, you want to return the E. How do I get the E given a 4? Okay, and so how do I write that? Like that. Let's go look at our error message. And I want to print up here. All right, so we'll call encode Rot13, passing it, in this case, our R. It should encode it. We want the answer inside of answer, and then we'll see that R maps to whatever it maps to. That's our desired output. Print, thank you. So it's yelling at me and saying that this guy, we're trying to use a subscript on something that isn't an array type, isn't a vector type. What kind of value is C? Go back in here. Oh, I'm sorry. It's not C, it's alphabet. I assume what you meant. So what kind of value is C? Or I'm sorry, alphabet? That's a char pointer. So our R maps to an E. Now, What if I said you can't use array syntax like that? You have to write it using memory mapping. You have to do pointer math to do this. So we're not allowed to say return alphabet at bucket index. Instead, we want to deal with index as an offset from the base address of alphabet. So how do I rewrite that line? Doing it with pointer math. Yep, good. So that's the value found at alphabet plus index. Go to the base address, add this many steps to it, give me the value you found there. Okay, so R still maps to an E. Okay, so now for in code Rot13, I want to do this for the entire string. Okay, so this guy no longer is taking in just a single char. Or maybe we say, maybe we have another function here. So we have a char who's going to return a char pointer. And this guy is called encode Rot13 string. And he will take a char pointer as a parameter. And this function, so this function is taking in a string, and he's ultimately going to return a string that is the original string turned into a Rot13 version of itself. Okay. Now, first thing, I'm gonna, well, here, I'll have you do it the wrong way. Well, I'll have you do it the less cool way first, and then we'll fix it. All right. So I'm taking in this string S, and I want to encode the entire string using Rot13. So I want to go through bucket by bucket by bucket by bucket, ultimately putting characters into a new string. Which character? The mapped version of that character. All right. So my first question here is how big will my output be? So when I return a char pointer here, which is the encoded version of S, how big, how many characters will be in my return value?
Same amount as S.
Same amount as S. And how many characters are in S? Generically speaking, how many characters are in S? I have a tool that tells me, right? So can't I say int length is equal to string length of S? And that'll tell me the number of characters that are in S. Okay, so now I need my answer to be able to hold that many characters. How do I make my answer? My answer is going to be another char pointer, but I need to own the memory that is capable of holding length number of characters. How do I own that memory? I'm creating my result string, right? If we're in a language like Java, what do? We do something like we say, string answer is equal to the empty string, that we start concatenating onto that dude and everything's fine. And you can pull this off using the string library in C as well, because there's a function called strcat for string concatenation. But we're not going to use that, okay, because we want to work with things here at the pointer level, because some of the libraries we're going to be using here in the second half of the semester are not going to be the newest, freshest libraries off the assembly line. They're going to be using some very old type stuff. So we want to operate inside of that headspace. So how do I create enough memory that I own? Because we want to be good stewards of our memory, right? We don't want to just jump somewhere in memory and just start writing crap, even though C will let us do it. No problem. I can just randomly pick a memory address, right? You know, I can just say char pointer answer. is equal to 0x123 FFF. Okay. It's kind of like, you know, when the well, Columbus or Amerigo Vespucci, depending on the, comes over here and there's already Native Americans living here. Just put down a flag. This is my land, right here. So I didn't ask the operating system. I didn't consult anybody. I took that memory address. Probably not the wisest thing to do. Who knows who lives there, right? All right, so how do we ask for enough memory directly? Okay, so the less cool kids way of doing it, so Malik is the answer I was looking for there. Less cool kid way of doing this thing would be to create a char array called answer of length, right? That'll give me enough memory. All right, so this is syntactic sugar for the cool kid. Include standard lib, I think, right? And now I can come down here and I can actually say I want char pointer answer to be equal to malloc of length. And since this is chars, it'll be that guy. Malloc is going to give me a void pointer. So I actually want to turn this guy into a char pointer. So I'm asking it to memory allocate this number of bytes. And since a char has size of 1, I mean, we can actually write this. We can say times size of char. I'm saying give me this many of this kind of thing. What's wrong with the size up there? Oh, because it comes back as that size T thingy. All right, so memory allocate enough buckets for this many of these guys and store that base address of that guy right there. Make sense? All right, so now we'll have, and I'll just go ahead and, well, I'll leave it at this. So for our homework, we want to finish writing this function such that it returns a new string, which is S encoded in Rot13. I'm going to say you should use old school pointer math whenever possible. Make some sense?
Is S just a single character? Or is
Nope, the base beginning of a string. So the idea here, so if I were calling it from up here, just to show you the quick example. In main, I might call encode Rot13 string hello, for example. And it should spit back out the encoded version of this guy, char pointer, encoded string. And then I should be able to do a printf. Encoded string is %s encoded string. I'll let you do this. You can use the %s for that. That didn't require standard lib or string.h to make that work. Otherwise, you can go through and print it one character at a time if you want to write your own function. That's what the cool kids would do. All right. Make sense what I'm asking you to do? Finish writing this for encoding. All right. I will push this thing so you have my current starting point or whatever. You can write your own. And I will see everybody on Monday.
Is there even cooler kid method to doing this? That you could just like route it directly using that ASCII?
Oh yeah, that would be a very cool way of doing it. That's what we're going to do in class next time, but I challenge you to do it for your homework. Yeah, because then you don't even have to look up the index, do you? Yep. And I guess I'll say out loud, I'll put it in the assignment too if I think about it, but you can presume everything's in lowercase for the assignment, right? Or if you want to be really cool, you can write your own function that converts it to lowercase or converts it to uppercase using ASCII math, like you were pointing out. But we'll look at that more next time. But again, if you want to challenge yourself with that kind of thing, that would be a fun type project. If this feels a little on the easy side. Not that it should, but if it does. All right.